Okay, Chapter 10 review. Chapter 10 is circles. It is a whole page of your formula sheet, but it is the exact same formula sheet that you have had before. The exact same one before. You do not need everything, but I just wanted to keep it the same so you knew where everything was. Okay, Chapter 10 review. I'm going to be very judicious today. I think that's the right use of that word. And we're going to talk about the things you need to know. So there's a lot of stuff in Chapter 10, and not everything made it on the exam. There are 7 questions from Chapter 10. There's more than 7 ideas. So I'm going to try to talk about 7 ideas today. Okay, let's talk about...
Are there any questions from our test on the exam?
Like exactly? Yeah, maybe. I think I can't think off the top of my head, but knowing Mr. Goodrow, I probably got lazy and just threw it on there. Okay. Let's do one from the test then. I want to do number 1 from your test. We didn't have one of these on the... Oh no, that was a different question. Okay, number 1 on the test was something like this. We had a big circle with a diameter. That was point A. Inside that, we had another circle. That was point B. And then C even subdivided that. And that's D over here. Pretend these are perfect circles. We were told diameter of D is 4 inches. Diameter of B is 9 inches. And diameter of A is 18 inches, which that should make sense because B is half of A. Diameter and radius double in half, respectively. And the question on your test said, what is C to A? Well, the only thing this question is cutting diameters in half or doubling radii and adding and subtracting. I know this is 9. Either that's the diameter of B or half of A, whichever you want to think about it, but that's 9. And my orange piece is almost that. I just have to figure out what this little sliver is not included is. What is that sliver? What is that little sliver? Well, that is circle D, and it has a diameter of 4. So that means right here is 4. So that means that little sliver is 2. So AC is 9 minus that little sliver of 2. So AC is 7. It's just adding and subtracting radii and diameter. So we sometimes had to cut them in half, like 4 had to cut in half into 2. 9, I cut from 18. We just have to manipulate it. And we can draw on the paper. It's a lot easier on the exam if you just physically write these numbers. Helps you see it so you're not thinking about it in your head. All right, questions on that kind of thing? We did those in the first section. This is like 10-1. Yeah. There is a question that we did that is not on your test that we're going to do today. So there's a good kind of question that we didn't do on your test that we're going to talk about today. So make sure you're not just using your tests. Because sometimes we chop stuff off.
Are those in inches?
Yeah. Let's say inches. It'd be no different if it was centimeters. Okay. Let's move on to the next one. The next thing I want to talk about is arc length. Arc length. I'll do black for the circle. Let's figure out what this this is real quick, so I can give you an exact kind of question. Let's call it 149 degrees. Okay. How long is arc L? And let's make up a radius. Lee, give me a number. 9. Perfect. So, here's a quick, simple arc length problem. You had one on your test, I think one on your quiz. On your circle formula sheet, this exists right down here. Has a nice little title, says arc length. We're using that. All we are doing is this. The length is the circumference times the ratio of how much we're using. So if the whole thing is 100 centimeters long and we're using half of the circle, it'd be 50 centimeters. The exact equation is this. So the length is 2 pi r times x over 360. Like I said, that's on your sheet right here. Two pi r, 2 pi and 9, and then 149 over 360. 2 pi and 9 is 18 pi. I'll turn that into a decimal. That is about 56 and a half. It's about 56 and a half. And 149 and 360 is about 41%. Of course, you can just put this whole thing in your calculator. I'm just showing you the pieces of it. I recommend putting it all in your calculator at one time, but I just want to show you the pieces. And I got 23.4. Which should make sense. The whole thing is about 56. I imagine this much would be exactly half of it. We're pretty close to half. So that seems to be close enough. We're using about 43% of 56. That's here. This whole thing is, you can just put that straight in your calculator and it would spit this out. Hopefully you understand by now, 1 decimal place is good for me. I'm happy with 1 decimal place. All right, questions on arc length problems. Cool, cool, cool. Like I said, your formula sheet is needlessly full. Like, we don't have a question on all of this. There's only 7 questions from this chapter, but I wanted to give you the same formula sheet so you're not thrown off by finding new things. You know exactly where things are, you've used it before, and you can always refer to it. All right, let's talk about, I don't even know what to call this part. All right, we have a circle with a diameter and a chord. See if I can get some kind of actual numbers on this. Let's say my diameter is 10 centimeters.
Is that chord split directly in half?
Yes. And let's say that chord is why is measuring not working right now in my brain? I guess it's okay. Let's say the chord is 8 centimeters. And we are looking for this value right here. If you want another example, think quiz 10. Oh, shoot. think number 6. Quiz 10, number 6, I believe. So we have a couple things. This is being hit at a 90-degree angle every time in this problem, which means these are the exact same length, which also tells me they're 4 units long. 4 centimeters long. Well, I know my final answer is smaller than 5, right? My radius is 5, that's half of the diameter. So, anyone remember how to solve this?
How do you make a triangle?
Make a triangle. We make specifically a right triangle. Specifically, make a right triangle because anywhere I draw a radius from the center to the outside has to be 5 centimeters long. I could have drawn a radius right here, but that's not helpful. It's still 5 centimeters, but I drew one to make a right triangle, and I know every radius I draw is 5 centimeters because it's half the diameter. So this is now the question we're doing. 4, 5, x, and it's a Pythagorean theorem problem. This actually is a Pythagorean triple, which means it is a whole number. We have 25 is x squared plus 16, move this. 9 is x squared, so x in this case is 3. It's not the most accurate diagram. Like that looks like 3, and that means that would be 2, but we're following the math right now. Okay. So you can see this one is a little challenging, especially if you don't know what you're doing, you don't know where to start. We have to draw a triangle. We know that any radius we add is the same as all the radii. We knew the diameter was 10, so we knew adding another would just be 5. I split this in half. This chord is shorter than the diameter, so it's 4 and 4. Questions on this? This wasn't on the test, but it will be on the exam. Okay. What's next? Yes. Easy stuff. I probably should have done this before. We talked about this one right before we did what I just showed you. And it was something like this. We had a circle, and we had some chords and arcs. Some chords and arcs. And the idea was this. If the chords were the same, the arcs were the same. For example, really easy property. It's just one of the ones over here. It just says congruencies. We have 5x plus 6, 6x minus 2. Even though this is talking about the chord, and we know the arcs match, just the properties of circles is if these match, these have to be the same amount. We can't select the right amount of arc with a different amount of chord. So all we have to do is this. So x is 8. Maybe I want x. Maybe I want to plug it back in. It's no different to do that. That'd be 40 plus 6. That'd be 46. Or 48 minus 2. So we could do that as well. That was one of the easier ones we did. We did this and this the same day. And we really didn't spend a lot of time because they just match. They're just congruent. So if we have an algebraic expression, we can just set them equal. And if we need to plug it back in, we can. Okay. Cool. More circle things. We have inscribed angles. Inscribed angles. For example, we have a big circle, and we have angles that don't originate from the center. They're not like a pizza slice, but they're something like this. They go out really big, from one of the sides of the circle. Let me get my measurements on what these actually are. Well, that would be, let's say that's 60 degrees, and let's say that this arc is 44 degrees. And we can find things based on this. What is the measure of this inscribed angle? Not the length. What's the degrees? 120. We take this 60, it is twice as big as the inscribed angle. Conversely, we can go backwards. If we have 44 for the arc, it's going to shrink in half. It's like a megaphone or a crescendo in music. It's getting bigger or it's getting smaller. It shrinks from 44 down to 22, or it doubles 60 to 120. Inscribed angles. I won't go too in depth on these. I just kind of wanted you to know the very simple ideas of how they work. For example, number 4 on your test. Very similar kind of question. Remember, on your exam, I'm not trying to find the special cases for any idea. I'm trying to give you like the base knowledge of all the things we've covered across the semester. So you don't have to be worrying about, well, the one case where this is like this. I'm going to try to be very fair on that and give you the base case for all of the ideas. Okay. Questions on inscribed angles? We also talked about inscribed shapes. For example, on your test, we inscribed a quadrilateral. We also circumscribed a circle using tangents. Neither of those made it on there. So, neither of those made that on there. Those kind of go hand in hand with what we just talked about, but they didn't make it. What did make it, though, was 2 kinds of circle problems. We have one where we have 2 chords, like such. Let me talk about the lengths, and let's talk about that first. I'm going to say this is 7. I'm going to look for this. I'm going to say that's 3, and I'm going to say this is 9. And we're finding x. These are the lengths. We know 3 of them, and we're missing that 4th one. We're missing this measurement right here. Now, they are not the same length, right? The further away you get from the center, the smaller it has to be, right? So a chord right here is smaller than here, and then over here. So this chord is going to be smaller than this, but they are still proportional, kind of. I like to think of it as proportionality. And what we have to do is multiply 3 times 9, those pieces together, and these pieces together. And that is true. 3 times 9, 7 times x. 27 equals 7x. That's not a whole number, but it's really close to 4. It's really close to 4. Say 3.8. So there we go. There's that idea. First, with the length, they are proportional. And if we wanted to find the arcs, like A, B, and C, the measure of these arcs in degrees, all we have to do is take the average. All I have to do is take the average. I'll put degrees as well. B degrees, A degrees, and C degrees. It's just the average. So crisscrosses, we have 2 things we do. Either we're multiplying the legs, each part of the legs together, or we are finding the average. As you can see, these are pretty good for like multiple choice questions. They're not like a lot of work. They're just kind of one thing. If you know what you're doing, it should take just a second. to plug it in, get an answer. So this kind of stuff is, hopefully as you're trying to think, what am I going to ask, this kind of stuff is great for multiple choice. All right, we're going to do one more kind of problem, and that will cover all the things we did in Chapter 10. Well, all the things that are showing up on the exam.
Do we have one more unit after this, or is that?
We do have one more unit. It is Chapter 12, but I'm choosing not to cover it. We just did it, and so it'd be very similar to the test review. And your test is almost perfect. I think it's the exact same kind of questions. Yeah. So that one I have the least worries about, and I think people did the best on that test. As a whole. Maybe personally someone didn't, but I thought as a whole people did good. All right. Final circle thing. Also final note of freshman geometry. Or sophomore geometry. We had... I will not. As of right now, I will not. Let's find out what these angles. I'm going to get relatively actual angles. Let's call that 33 degrees. How am I going to find this one? Let's say that is 110, I think. I just want to get something that's approximately the right numbers. And we are looking for, we'll call this y degrees. I'll show you why it's y in a moment. And then we'll talk about the legs as well. I want to spend more time on the degrees than the lengths for this one, just because that just ends up being more common for us. On our formula sheet, we have this formula. We have the measure of angle 1 is equal to 1/2 x degrees minus y degrees. That's slightly different than we talked about it in class, but I wanted to keep true to the formula sheet. And so what they're talking about, this is angle 1, this is y, that's why I did y, and this is x degrees. So 1 outside equals 1/2 big minus little. It's the exact same thing, and you can see the diagrams walk you through how to do it, hopefully. So that means if I wanted to plug all this in, it'd be something like 33 is 1/2 of 110 minus my variable. That's the setup. First thing I'm going to do is double each side to get rid of that 1/2. 66 is 110 minus y. So 110 minus some number gives me 66. And that would be 44.
Okay, what's the way you taught us to do it?
The way I talked about it in class was this. And it's the same, it's just this equation. 2 times the outside equals big minus little. It's the exact same thing. That's just not on the formula sheet because that is just using words instead of mathematical notation, but it is the exact same thing. And then if we did care about the lengths, so for the legs, it was the outside piece times the whole length equals the outside piece times the whole. So if we knew each of these, we could multiply them together. Did you have a version of that on your test? You did. Like number 8 on your test? I'll do number 8 real quick. That'll be my last problem. To end the year, yes sir. Keep it out there for just a little bit longer. Okay. Number 8 from your test. Oh, and one sheet left. Perfect. Something like this. That's 3. That's 5. That was 2, and this is x. Okay, that was what it looked like. Just about. So the outside times the whole. The outside here is just 3. And the whole is 8. 3 plus 5. Outside's 2, and the whole is x plus 2. Because x is just the inside. It is not the whole line. It starts out here, goes through the 2, and there. So I have to distribute. 24 is 2x plus 4. Take that away, take that away. X ends up being 10.
Why did you just distribute?
Because it's 2 times a polynomial. That x plus 2 are kind of linked together. So they get parentheses off. And with that, we conclude our review for the exam. You have some stuff from chapter 12, but I think if you study your test and your most recent notes and all that stuff, you'll be good. And also, if you have any questions, I would love to see you on Friday and have everything answered.